Last week, millions watched as solar storms painted our skies with spectacular auroras. Beautiful, mesmerizing, and relatively harmless. But 130 light-years away, astronomers just witnessed something far more terrifying. A stellar explosion so powerful it could strip the atmosphere off an entire planet, leaving behind nothing but a barren rock. And it's the first time we've ever detected this phenomenon from another star. Here's what this groundbreaking discovery means for the search for alien life. To understand what astronomers discovered, we first need to talk about coronal mass ejections, or CMES. These are massive eruptions from a star's outer atmosphere. Enormous clouds of ionized gas and magnetic fields blasted into space. When our sun releases a CME that hits Earth, it creates those beautiful auroras at our poles. But it can also disrupt communications, knock out power grids, and interfere with satellites. We call this space weather, and while it can cause problems, Earth's magnetic field protects us from the worst effects. But here's the thing, until now, astronomers had never actually detected a CME from any other star in the universe. These events happen too far away to observe directly, or so we thought. Enter a team of astronomers using cutting-edge software to analyze data from LOFAR, the Low Frequency Array, a massive radio telescope made up of thousands of antennae spread across Europe. They were studying STKM 1-1262, a red dwarf star located 130 light-years from Earth. This star is only half the mass of our Sun, but it rotates 20 times faster and has a magnetic field 300 times more powerful. Then they saw it, a coronal mass ejection racing away from the star at a blistering 5.3 million miles per hour. That's a speed our Sun only achieves in about 1 in every 2,000 CMEs. According to study co-author Cyril Toss from the Paris Observatory, quote, "The star behaves like an extremely magnetized boiling bucket of plasma. This burst is 10 to 100,000 times more powerful than the strongest the Sun can produce." The key to detecting it was identifying a specific radio signature called a Type II radio burst. Unlike fast radio bursts that last milliseconds, this signal evolved over minutes as the hot gas swept away from the star. The team used a new analysis technique called RIMS, Radio Interferometric Multiplex Spectroscopy, specifically designed to catch these fleeting events by monitoring thousands of stars continuously. Now here's where this gets really important for the search for life. Red dwarf stars like STKM 1-1262 make up over 70% of all stars in our Milky Way galaxy. Scientists constantly find exoplanets orbiting these stars, often clustered very close to them, sometimes completing an orbit in just days. Because red dwarfs are cooler and dimmer than our Sun, planets need to be close to stay warm enough for liquid water. But here's the devastating catch. When a CME this powerful hits a nearby planet, even Earth's protective magnetic field wouldn't be strong enough to withstand the pressure. The atmosphere would be stripped away, exposing the surface directly to the stellar wind and radiation. Even if the planet is in the perfect habitable zone with liquid water, repeated bombardment would leave behind nothing but a barren rock, kind of like Mars. This discovery fundamentally changes how we assess whether planets around red dwarf stars could actually support life. Having liquid water isn't enough if the star keeps blasting your atmosphere into space. The good news? This is just the beginning. The square-kilometer array, set to be completed in 2028, will be the world's largest radio telescope, capable of detecting CMEs from stars across the galaxy. Researchers now want to understand how these small stars build and release such enormous energy, and determine just how common these atmosphere-destroying events really are. As we search for life beyond Earth, we're learning that the universe is far more violent and dynamic than we imagined. And understanding stellar storms like these is crucial to finding worlds that could actually harbor life. One star, 130 light-years away, just changed everything we thought we knew about exoplanet habitability. And this is only what we've found so far.